Hello YouTube friends, in this video I'm going to be proving to you geometrically, that is with a diagram, the one we see to our left, that when you get the squares of natural numbers in order, you end up with n/6, okay, multiplied by n+1 multiplied by 2n+1. Now, to understand this proof, there are three things that you will need to know. The first thing is that the area of a rectangle is equal to length times height. Okay, so that is length, okay, and that is times height. The second thing you need to know is that when you have the sum, okay, of all the natural numbers up to n, which is the number of terms, that is 1 plus 2 plus 3 plus 4 plus ... plus n minus 2 plus n minus 1 plus n, okay, you end up with n/2 multiplied by n+1. This is vital. And the third thing you'll need to know is that half the sum of the squares of all the natural numbers up to n, which is the number of terms, plus n/4 multiplied by n+1, where n is the number of terms, is equal to 1 plus 3 plus 6 plus 10 plus ... plus n minus 2 over 2 multiplied by n minus 2 plus 1. Let me just go down. Plus n minus 1 divided by 2 multiplied by n minus 1 plus 1. And finally, plus n/2 multiplied by n+1. Now, if you want to understand why this is the case, alright, why this over here is equal to all of this, then I would advise you to watch the video that I've placed below this video. There's a link to it, and it's a 40-minute video, and it will explain why this is equal to all of this over here. Okay? I would recommend watching this video because this formula here is going to form a very vital part of the proof. So watch that. The link to that video related to what I'm saying is at the bottom of this video. Just click on it and you'll be directed straight to it. Of course, if you've already seen that video, then we can proceed with the proof. If you're just not curious about finding out why this is the case, then you are welcome to proceed with the proof anyway. It doesn't really matter. So let's begin creating this proof, and get a pen and paper ready because we are going to do quite a bit of work. Okay, so let's start working on this proof. The first thing I want you to do now is to have a look at the diagram to the left. It consists of a rectangle, and inside this rectangle you see some squares, okay, shaded in yellow. These squares are equal to 1 squared plus 2 squared plus 3 squared plus 4 squared plus ... plus n minus 2 squared plus n minus 1 squared plus n squared. Okay, this is what these squares in yellow are related to. And in terms of equations, they're related to this equation over here, okay, which is 1 squared plus 2 squared plus 3 squared, etc., etc. So we are going to label this formula over here in yellow, okay, and it represents all the squares in yellow within the rectangle that we are looking at, okay? Now here's the thing, these yellow squares make up part of the rectangle, but not the entire rectangle. There are other pieces to this rectangle that are making it up, okay? And they are these red pieces over here. And if you have a look at them, okay, very carefully, you'll see that the smallest one here in red, the smallest box filled in red, is equal to 1. The second smallest is equal to 3. The third smallest is equal to 6. Then you get a rectangle of 10. Then you get a rectangle of plus dot 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 plus. Then you get a rectangle of n minus 2 over 2 multiplied by n minus 2 plus 1. Then you get a rectangle of n minus 1 divided by 2 multiplied by n minus 1 plus 1. Then you get a rectangle of n divided by 2 multiplied by n plus 1, okay? And these rectangles in red help fill out the entire rectangle, okay? So the entire rectangle is made up of the squares in yellow, and it's also made up of the rectangles in red and the small square in red over here, okay? Now everything in red is going to represent what we've got here as the third thing we need to remember, okay? It represents this formula over here, okay, which is 1 plus 3 plus 6 plus 10 plus dot dot dot, etc., etc. Therefore, we are going to label this in red, okay? We are going to label it in red, and it represents everything we see in red over here on this rectangle, this diagram that we have. This is very important to know. Now, I've spoken about the substance of the rectangle, everything inside it, its area, you know, the things that are represented in yellow and red. Now I am going to begin talking about the lengths, okay, because this is going to be vital when formulating our proof. Okay, over here I've labeled this length, okay, n+1, alright? And that is because the length of this square at the top, the largest square, shaded in yellow, is n, okay? And the length of this rectangle over here is simply 1. Therefore, this length, okay, in its entirety, is n+1, okay? And I'm going to put that down right over here. The length is n+1 because we are going to need the area of the entire rectangle to formulate our proof. Now I've labeled the height of this rectangle n/2 multiplied by n+1, okay? This is because the height of this rectangle represents this equation over here, okay? That is 1 plus 2 plus 3 plus 4, etc., etc. It's just these sums added up. I'm going to explain why. It's because the length of this small square in yellow, or the height, is equal to 1. the height of the second smallest square is equal to 2. The height of this one, 3 squared, is equal to 3. The height of the 4 squared square is equal to 4. This height is equal to plus dots 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 plus. This height over here is equal to n minus 2. This height over here is equal to n minus 1. And this height over here is equal to, let me just make that clearer, n. Okay? So as we can see, the height of this rectangle over here represents this equation right over here. I'm actually going to write that down over here. Okay, n over 2 multiplied by n plus 1. The height of this rectangle is equal to this. Okay, so the area of the rectangle is in fact going to be equal to, this is the large rectangle by the way, n over 2 multiplied by n plus 1 squared. Alright, now with all of the logical hurdles out of the way, we can now get to the meat of the proof. And maybe you've already figured this out, but all we need to do to get the value of this now is to get the value of, or the area of the entire rectangle, then subtract the red parts from it, okay? Because if we subtract the red parts from it, we are going to end up with just the yellow squares, and that's exactly what we want, because the yellow squares represent this equation here, which is n over 6 multiplied by n plus 1 multiplied by 2n plus 1. So if we get the area of this entire rectangle, subtract or strip away the red part from it, we are only going to be left with the yellow squares, okay? And that's what creates our proof. Okay, we're now at the exciting part of the proof, and we're only moments away from completing it. What we're going to do is get the area of the rectangle, which we know is n over 2 multiplied by n plus 1 squared, and we are going to subtract the red parts from it, okay? And we already know that the red part is represented by this equation or formula over here. Okay, so let's get to the end of this proof. Alright, so I'm going to get the area of the rectangle, which is n over 2 multiplied by n plus 1 squared, and I'm going to subtract the red parts from it, okay, which is half this, okay, which we've already established up here, plus n over 4 multiplied by n plus 1, okay? So we're getting that entire rectangle and we're subtracting the red parts from it, and if we do that, we're going to be left with all those yellow squares, and that is equal to this, okay? And the idea of this equation right here is to prove that this, okay, over here, is in fact equal to this, and that's where we're going to get to. Okay, so let's start simplifying this equation, and let's get our proof. So from here we end up with n over 2 multiplied by n plus 1 squared minus half this. Okay, let me just make this clear. Minus n over 4 multiplied by n plus 1. Okay, which is equal to this. Let me just make this clear. Alright, and from here we are going to get 3 over 2, this, okay, is equal to n over 2 multiplied by n plus 1 squared minus n over 4 multiplied by n plus 1. This is because we added this value over here. Okay, I'm going to put it in red. We've added this value over here to both sides of this equation, to this side and also to this side. So instead of having just one of these, we have 1.5 of these, and that's in fact 3 over 2. So we end up with this, okay? And we are going to simplify even further to get our proof. Okay, so from here we get this over here. And this is going to be equal to, let's say, n over 2 multiplied by n plus 1. Then this is going to multiply inside brackets n plus 1, and then let me see, minus a half. Okay, so we're using the distribution method to simplify this equation further, and we've got this, and there's still some more work to do. From here I'm going to speed things up a little so we get to this proof more quickly. So we end up with this, okay, and this is going to be equal to n over 2 multiplied by n plus 1. Then in brackets we can say 2 multiplied by n plus 1 over 2 minus a half, okay? Because 2 over 2 is equal to 1. And if we do this, we get this again, okay? And it's going to be equal to n over 2 multiplied by n plus 1, then multiplied by this in brackets. That is 2 times n plus 1 minus 1 over 2. Okay. And then this is the same as this is equal to n over 2 multiplied by n plus 1 multiplied by, in brackets, 2n plus 2 minus 1 over 2. Okay, and as we can see here, we've got a plus 2 and a minus 1, so this at the top becomes 2n plus 1. Okay, so what we end up with is 3 over 2 multiplied by this, okay, and that is going to be equal to n over 2 multiplied by n plus 1 multiplied by 2n plus 1 at the top here over 2. And we can simplify this side of the equation. If we do that, we're going to get 3 over 2. This, okay, is equal to n over 4 multiplied by n plus 1 multiplied by 2n plus 1. And we're incredibly close to getting this proof. Okay, now let's multiply both sides of this equation by 2 over 3, okay? Because if we do just that, we are going to be able to isolate this, okay? We get this on its own. So we've multiplied both sides of this equation by 2 over 3. Now, if we do this, we end up with this, okay? And 2n multiplied by n+1 multiplied by 2n+1 over 12. And you know exactly what's going to happen from here. So the sum of all the natural numbers squared up to n terms, okay, is going to be equal to, let me see, n over 6 multiplied by n+1 multiplied by 2n+1. And we have our proof. How cool is that? We got this diagram over here, messed about with it a bit, subtracted the red part from it, synthesized what we know with algebra, and we ended up with this. If you like this video and you like my work, make sure you are subscribed to me, and also visit my Instagram account to support me. That page is actually on the screen right now. There's a donate link below this video, and if you want maths proofs, there's another Instagram account that you can access at the bottom of this video. Just click on the link. Thank you very much for watching, and stay tuned for more proofs.